Well, this is the last video for Math 70. I'm going to go over the sample final exam. Your final will have the same number of questions and the same types of questions as the sample final. They'll just be different questions. Okay. So, and also I want to point out that there will be a formula sheet on the last page of that sample final is going to be a formula sheet, and I'll try to make sure to do the same thing for the final exam itself. All right, so let's go ahead and get started. And this will, if you want to review, you can go back and look at the assignments and quizzes that we've been going over, because all of those assignments and quizzes are geared towards the questions on the final. So, problem number 1. Let's see here. We want to evaluate the expression y minus x all squared over x plus y if x is negative 4.82 and y is 6.08. And then we want to round this to the nearest hundredth, which is 2 decimal places. Right? It's always the same number of decimal places as there are zeros. Let's get the calculator out. Well, first let me write this down. We've got 6.08 minus, this minus comes from the formula, this minus comes from the value of x. Okay? Then that's all getting squared, and then x plus y. Okay? So a couple things to point out. Again, I pointed out that issue that this minus sign comes in the formula, but this negative sign comes from the value of x. And it's important that there are 2 of them, because this will then become addition. You can do it on your calculator as subtracting a negative if you want to. It doesn't really make any difference. It'll come out to be the same value. The other thing that I want to point out here is that we need to calculate the value inside the parentheses first. Get that down to a single value and then square that single value. All right, so let's go ahead and do that. Let's see here. 6.08 plus 4.82 is 10.9. So 10.9 squared on top, and on the bottom, negative 4.82 plus 6.08, 1.26. Okay, so let's take that 10.9 and square it. 118.81, and then we'll divide by 1.26 and round to the nearest hundredth, which is going to be 94.29. Okay. Problem 2. Problem 2. Notice problem 2 says simplify. I'll point out 2 things about problem 2. First, I'll write it down. 5 times 4 plus x minus 3 times x plus 9 minus 7 minus 2x. Okay, so the first thing I want to point out about problem 2 is that the instructions say simplify. Also, notice there are no equal signs. Okay, so this is not an equation. We're not solving it. All we're going to do is collect like terms, okay, and distribute. Right, so we have to distribute the 5, that'll be 20 plus 5x, then distribute the minus 3, minus 3x minus 27, and then those other pieces just stay the way that they are. All right, now we want to collect like terms. Remember, the sign for every term is in front of it, okay? So, plus 5x minus 3x minus 2x makes 0 x's. You can write 0x if you want. I won't mark that wrong, but in most cases people just leave leave that out. Okay, so those all just cancel each other out. Let's see here. 20 minus 27 is negative 7, minus another 7, negative 14. And there we go. Okay. Now, starting with problem 3, 3, 4, 5, and 6, the instructions say solve. Okay? And you'll notice that these all have equal signs. They're all equations, 3, 4, 5, and 6. And so, yeah, we want to solve these. There's a difference between something that we just want to simplify, has no equal signs, versus something that we want to solve, which is an equation. So, negative 0.50 times 15 minus 0.35 times x plus 5 equals 0.75x. Okay, so let's get rid of the parentheses in here. 15 times negative 0.5 should be negative 7.5, right? Because this is a half. And then we'll get minus 0.35x. And then minus, let's see, what is that going to be? 150 and 25, is that 1.75? Let's see here, I'll double check so I don't make a mistake here. Negative 0.35 times 5, yeah, minus 1.75 equals 0.75x. Then I'll add the 0.35x over to collect our like terms. Well, I shouldn't say that. I shouldn't say collect like terms, because that's kind of what we're doing over here when we're simplifying. Over here, I'm getting all my variables on one side and keeping all of the non-variable terms on the opposite side so that we can isolate the variable. Okay, so I'll add that 0.35x to both sides in the equation, right? This cancels out. Over here I've got negative 7.5 minus 1.75. I'll double check this. It should be negative 9.25. And then let's see here. Yeah, 9.25. And then here there should be 1.1x, right? 0.75 and 0.35. There we go. And then we'll just divide on both sides by 1.1. And so x is equal to negative 8. We can round this off. We can say approximately negative 8.41. It is a repeating decimal, so if we want to be exact, we can call it 409 repeating. Okay? So really, the only repeating decimals that I tend to make a big deal about are things like 1/3 the repeating 3, 2/3 the repeating 6, and so on. Simple repeating decimals I expect you to be able to work with, okay? If you run into something that's a little bit trickier, even this one's not so bad, but I would be understanding if you rounded it to negative 8.41, that's fine. But try not to get in the habit of thinking of those repeating decimals as non-repeating decimals, because they're not. Okay. The other thing that I'll point out is this squiggly equals to indicates that you know that you've rounded this off. Okay. This says x is exactly equal to this number. This says x is about this number. Okay. And so if you do that, you're communicating to me that you understand, yes, I've rounded this off, as opposed to saying that x is actually equal to that number, which it's not. It's approximately equal to that. All right, problem 4. Let's see here. 9 over x minus 5 equals 4 over x. So remember we had that assignment on solving proportions. Where I talked about how if you cross multiply with these two fractions, if they're equal to each other, when you cross multiply, then those results will also be equal. Okay? And I talked about why that's true. It has to do with common denominators and everything, but this is the shortcut version. So now let's go ahead and distribute 4x minus 20. Subtract the 4x on both sides. 5x is negative 20. Divide on both sides by 5. And so x is equal to negative 4. All right. Problem 5. Now we've got the one with all the fractions in it. And this is kind of what I was talking about with the repeating decimals a few minutes ago, right? With that 2/3, if you call that 0.6, you're going to get a wrong answer. Okay? Let's see here. 3x and 27 over 8. All right. So a lot of calculators handle fractions really easily. Okay, I've got an older Texas Instruments calculator that handles these fractions in a really nice way. These calculators really don't handle fractions quite so well. They revert to decimals pretty quickly, but there is that fraction button. If you hit the math key right here, then choice number 1 will be turn it into a fraction. All right. Okay, let's see here. So the process here is the same as any other equation, right? We want to collect our x's on one side, collect everything that doesn't have an x on the other side. So I'll subtract the 2/3 on both sides, 2/3 x. Okay, so this will be 3/4. Over here, 3 minus 2/3 is 2 1/3. You can call it that if you want to. It's kind of tricky. These, like I was saying, these calculators are not so bad with regular fractions, but when it comes to mixed numbers, they are really terrible. So I'm going to do this as improper fractions. So this is 9 over 3 minus 2 over 3 makes 7 over 3. And then we've still got that 27 over 8 back here. So let's subtract that on both sides. 7/3 x, and over on the other side, again, you can do this on a calculator. These are terminating decimals. They lend themselves really nicely to being worked on a calculator, but this is 6 over 8 minus 27 over 8, so that should be negative 21 over 8. And then again, we can divide on both sides. I'll write it like that. Divide on both sides by 7/3, which actually has the effect of multiplying by 3/7. And so what we get out of this is negative 9 over 8. And if you turn these into decimals and you do it correctly, then you should get negative 1.125. Don't round it off. There's no reason to. It's a terminating decimal. Everything's fine. Okay? Again, if you want to turn these all into decimals to get started, that's fine. But when you do this one, carry around a bunch of these 6s. You know, don't round it off to just 1 or 2 places. I talked about this in one of the other videos, I think, unless it was a different class. You know, 7 or 8 of that repeating digit gives the calculator what it needs. And if you do that and you come down here at the end and you've got negative 1.124999999, be smart about it. Know that that's 125. It's not 1.249999, okay? All right, because if you're going to round this off, then you should round back at the end. All right, so there's the fractions problem. Let's look at problem number 6. Okay, let's see here. Negative 3 times x plus 2 plus 5x minus 4 on one side equal to 7 times x minus 3 minus 8 on the other side. Okay, so let's simplify everything and then collect all our x's on one side. Everything that doesn't have an x goes to the other side, and then we'll isolate the variable. So this will be minus 3x minus 6, and that 5x minus 4 doesn't change. Here 7x minus 21, and again that 8 just stays the way that it is. Okay, so positive 5x, negative 3x makes positive 2x, minus 6 and minus 4, minus 10. 7x and negative 29. Okay, so I'll subtract the 2x over to here, add the 29 over there. So minus 2x and minus 2x. Don't lose that minus sign, it's attached to the 10. 5x minus 29. And then add the 29 to both sides, so that'll be positive 19. And then the last thing we're going to do is divide on both sides by 5. So x is, you can leave it as 19 over 5 if you want to. If you divide it, you should get 3.8. Either one of those answers is fine. You can call it 3 4/5 if you want to. Okay. Now problem 7. Now we do this without numbers. Right? We've got b equal to a plus xy, and we want to solve for x. So, first thing we want to do is get the thing that has the x in it by itself, just the same way as we did over here, right? So, this doesn't have an x in it, so we want to move it to the other side. Subtract a on both sides. xy equal to b minus a. And now, just the same way that we divided by 5 to get the x by itself, we're going to divide by y to get the x by itself. And x is going to be b minus a over y, and there we go. Okay? It's a pretty straightforward problem. But it can be confusing since we're used to working with numbers instead of just having all letters. But again, I think I talked about in the assignment that we did on this type of problem, this is very common in the sciences where they have lots of formulas and they constantly want to isolate different pieces of the formula depending on what they're trying to do. So if you plan to go on in the sciences or take some science courses, then it's good to think about this, okay? All right, problem 8, absolute value. 2x minus 7 absolute value equal to 5. The fundamental idea of an absolute value is that there are two possibilities. 2x minus 7 could be equal to 5, or it could be equal to negative 5, okay? All right, that's half the problem right there. All right, next we just need to solve these two simple little equations. 2x is 12, x equals 6. Great. Over here, 2x is 2, and so x equals 1. And there we go. Okay? Problem 9. Okay, so this page is all about inequalities. So let's take a look at it. 5x plus 4 less than or equal to negative 10. And we want to graph each one of these on a number line as well once we solve the inequality. So, subtract 4 on both sides. 5x less than or equal to negative 14. Divide on both sides by 5. You can keep it as negative 14 over 5. What is that going to be? Negative 2.8. Okay. Oh, I dropped my equal sign. There we go. And then if we want to graph it, here's 0. Here's negative 2.8. So all the numbers less than negative 2.8 are down that way. All the numbers greater than negative 2.8 go this way. x is less than, it's pointing at the x, so that these are smaller, this is bigger, okay? So that's all going to be over here. The equals to says we want the colored in circle there, and then everything less than negative 2.8. Okay, let's see here. Problem 10. So 3x minus 5 less than or equal to 7x plus 19. So I'm going to do this problem two different ways. First off, I'm going to subtract 3x on both sides to move it over to be with the 7x. Okay? And then once I get done with that, I'll solve it the other way by moving the 7x over there. But for starters, this is, for one thing, if I'm going to move this 3x, the sign for it is in front. It's a plus, right? This negative goes with the 5, so don't make that mistake. If we want to move the 3x, we've got to subtract 3x on both sides. That leaves the minus 5 over there. This will be positive 4x plus 19. And then we can subtract 19 on both sides. And then we'll get 4x greater than or equal to negative 24. Divide on both sides by 4. And we get x greater than or equal to negative 6. And that's kind of the opposite of this one over here. Here's the negative 6. The equals to says we want to color in and include the negative 6. But this one says that the x's should be greater than the negative 6. And so it's going to be everything out in that direction. Okay. Now, what if I decided I was going to move that 7x over to be with the 3x instead of the way that I did it right there? So let's see here. 3x minus 5, 7x plus 19. So let's say I subtracted the 7x on both sides. That would be negative 4x minus 5 less than or equal to 19. Okay. Then I'll add the 5 over here. Negative 4x less than or equal to 24. Which is essentially very similar to what I have here, right? Except that the signs have been switched. This is a negative 4, this is a positive 4, this is a negative 24, this is a positive 24. So if you remember from the assignment that we did on inequalities, right? Right now, I'm about to divide by negative 4. And if I do that, it's going to flip that sign around and put it that way and say x greater than negative 6. Okay? The reason for that, again, is because, let's say instead of dividing by negative 4 the way that I did, what if I moved everything around? Okay? Now I've got what I had over here. See, the whole point of that flipping the sign is that multiplying or dividing by a negative has the same effect as switching sides in an inequality. And in an inequality, it's important which side you're on, okay? And so when you do this that has the same effect as switching sides, you've got to flip this symbol around. But you only do that if you divide or multiply by a negative number. Okay, let's see here. Well, let's take a look at problem 11. So, problem 11 is what they call a compound inequality. 8 less than 7x plus 1 less than or equal to 29. And it's called a compound inequality because instead of there just being two sides, like in a normal equation or inequality, now there's three different places, or three different sides, okay? And so, if I want to subtract this 1 to cancel that out, I've got to do it in three different places, okay? So this will cancel out the 1 and leave me with 7x. Over here I get 6. Over here I get 28. Oops, not 6. 8 minus 1 is 7. There we go. Okay. And now when I go in to divide by 7, I have to do that in 3 different places. So x is less than or equal to 4, but greater than 1. There's my answer on the number line. Less than or equal to 4, greater than 1, so the 1's not included, but everything up to the 1 is. That's why we have the open circle. And then we just color in between the 1 and the 4, and there we go. Okay. Problem 12. We want to graph x greater than -8 on this number line. So just go ahead and put the -8 to the left of the 0. The x's should be greater than -8, so that's going to be everything out here. We're going to put an open circle on here because there's no equals to there. And so there's all the x's greater than -8. Okay. Now we get into the graphing section. So the test paper has grids on it, just like the midterm did. I will approximate those grids on the board as best I can, but it's going to be a little bit different. Okay, let's see here. Problem 13. Graph the following equation. 4x plus 3y equals 12. Okay. Now you can do this any way that you want, so long as it's correct. Okay. What I like to do is put this into slope-intercept form and graph it using the y-intercept and the slope. If you want to leave it as is and plug in x and y values and generate some points, that's fine. There's nothing wrong with that. But this is how I'm going to do it. I'm going to move the 4x to the other side, -4x plus 12, and then divide everything through by 3. And notice how I divided everything by 3, not just this piece or this piece. I had to do all of it. So, -4/3 x plus 4. All right, so that tells us the y-intercept is at +4, 0, +4. And then the slope here is -4/3. So I can go up 4 and to the left 3. Or I can go down 4 and to the right 3. And there's the line. Okay? All right. Problem 14. And let's see, I'll put labels here, 1, 2, 3, 4, 5, and 1, 2, 3. So there we've got a sense of, okay, what the scale is. Problem 14, same thing. You can choose to do this however you'd like, so long as it's correct. If you want to just make a table of values by plugging in one variable for x and solving for y, or vice versa, that's fine. I'm going to divide everything through by 3, say y equals 4x plus 3, and then graph it. So there's the 5. Let's see here. So 0, 3 is our y-intercept, and then our slope is 4. So 1, 2, 3, 4, and then over 1, and then 1, 2, 3, 4, and over 1 more. And so this is going to look something like that. Okay. Again, it's not exact because I don't have a grid here, but you do have a grid on the test paper, and so your graph should be more accurate. Okay, So that's problems 13 and 14 on there. Now on the next page we get into this whole issue of writing the equation of a line and the issue of lines that are parallel or perpendicular. So, problem 15, we want the equation of a line in slope-intercept form, passing through the points -7, -5, and -2, 4. So I'll draw a little picture over here. You don't have to draw a picture to graph the line. And let's see, no, oh, -7, -5 will be down here, and then -2, 4 will kind of be right there. So our line should look something like this. So that gives us a sense that our slope is going to be positive, and our y-intercept is going to be up there somewhere up above 4. Okay? So let's see what it looks like. The slope formula is on your formula sheet. y2 minus y1 over x2 minus x1. And remember, if I take this y first, 4 minus -5, I have to take the -2 on the bottom, minus -7. The other thing to be aware of, again, these minus signs come with the formula. These minus signs or negative signs come from the values of x and y. And so this double negative will make this 4 plus 5, which is 9. These two negatives will make a positive, so -2 plus 7 is 5. So there's our slope, 9 over 5. That's fine. If you want to call it 1.8, that's fine too. I like to leave it like this because it tells me how far to go up and over, you know. All right, so let's see here. Now we say y equals 9/5 x plus b, and then plug in one of these pairs of values. If I choose the 4 for the y, I have to choose the -2 for the x. If I choose the -5 for the y, I have to choose the -7 for the x. All right, so let's see here. This will be, I'm just going to switch to a decimal at this point because actually we don't have to graph this. And so having the slope like this is really beneficial when you're on a grid making a graph. But all I need here is just the value of b. So that's going to be -3.6. And then I'll add that to both sides. And so b is going to be 7.6. So if you leave it like this, you've done pretty much the problem, but the problem is asking you for the equation in slope-intercept form, so we can call it 1.8x plus 7.6. You can use the 9/5 if you want to. You could make this some kind of improper fraction if you want to. That's all fine. But really, it's best, it really is a good idea. Your answer should be the equation in slope-intercept form rather than just ending with the value of b. All right, problem 16. Now we want a perpendicular line. Perpendicular to -3x plus 4y equals 8. And we want it to pass through the point 3, 2. So I'll do what I did when I made a video for this assignment, which is to draw a picture for this. You don't have to. You don't have to draw a picture to do this problem, but I found that people frequently get confused because there's a couple different things happening in the problem. All right. Well, first of all, let me get the y by itself over here, because we need to know the slope of this line so we can know the slope of the line that's perpendicular to it. Okay, so let's get there first. So first we'll get the y by itself. Divide everything through by 4. Y equals 3/4 x plus 2. Okay, so like I said, we don't have to graph this, but I'm going to anyway. There's our y-intercept, and then we'll go up 3 and over 4. And so it'll look something like this. Okay, now, we want a line that's going to be perpendicular to that, so it'll look like this, right? And passing through the point 3, 2. So here's 0, 2, and there's 3, 2. So this perpendicular line is going to look like this, okay, with a little right angle there. And now we want to know what's the equation for that line, okay? Well, the slope, if it's perpendicular, is going to be the negative reciprocal, negative 4/3. So we know it's going to be negative 4/3 x, and we don't know what the y-intercept is. It's going to be up there somewhere, but we can find out by taking this point 3, 2 that it passes through and plugging those values in for y and x. So that'll be negative 4 plus b. b equals 6. Okay, so our answer, y equals negative 4/3 x plus 6. And that's problem number 16. Okay. Problem 17. We want the x and y intercepts for this equation. 6x minus 5y equals 30. Okay, x-intercept, y-intercept. So the y-intercept is where x is equal to 0. The x-intercept is where y is equal to 0, right? Because here's the y-intercept, and down here is the x-intercept, okay? All right, so for the y-intercept, make x equal to 0. So that cancels, that's just going to be 0. So we're going to have negative 5y equals 30. Divide on both sides by negative 5. Y equals negative 6. It's best to answer this question as an ordered pair. 0, negative 6. Over here, let's make the y 0. So this drops out. It's 6x minus 0. Divide on both sides by 6. X is equal to 5. And again, it's best to answer this question as an ordered pair. 5, 0. Okay? So here are the y-intercept and the x-intercept for problem 17. Okay, problem 18 comes from that linear applications assignment. We've got this graph saying business purchased a computer for $1,000 in 2010. So that year 0 corresponds to 2010. And here's the point 0, 1,000. And then we've got this linear depreciation line that shows after 4 years, the accountants say the computer is worth only $800. Okay, that's the year 2014. Now we want to write the equation of this line in slope-intercept form. Well, if you're astute or looking at this carefully, here's your y-intercept right here, 0, 1,000, right? So we know that this is going to be y equals mx plus b. The problem is showing us that b is 1,000, okay? All we need to do now is calculate the slope. Change in y's, 1,000 minus 800. Over the change in x's, 0 minus 4, right? If I start with the 1,000 on top, I have to start with the 0 on the bottom. So 200 over negative 4, our slope is going to be negative 50, and there we go, negative 50x plus 1,000, and we're done. Okay. Problem 19. Now, we talked about a bunch of different methods for solving systems of equations. Here, you can use any method you'd like. Okay? You can graph these. You can use substitution. You can add them together. So this one doesn't really lend itself to any of those methods. Okay? After, spending all that time talking about all these methods for solution, because if we can get the y by itself here, but that's going to produce fractions. So I'll tell you what, I'll do this the two ways that don't involve graphing, okay? Because graphing here is, I think we're going to have non-whole numbers involved, and that's where graphing doesn't really lend itself. So first off, I'll do this by substitution. I'll divide everything through in this equation by 6. Okay, so y is now equal to, this reduces, it's a good idea to reduce this, negative 4/3 x minus 1/6. If you like decimals, then notice that these are going to be repeating decimals, and you should carry around those extra digits with you so that you get an accurate answer at the end. Okay? All right, well now if we know that y is equal to that, then we can go and plug it in up here. Negative 4/3 x minus 1/6, put that in place of the y in the other equation. And now we're going to distribute this 12, and that's going to actually take care of the fractions for us, won't it? Let's see, this is going to be negative, right? Because positive 12 times negative 4/3 is going to be negative 16, right? Because the 3 goes into 12 4 times 4 is 16, and then we still have the x there. Here, 12 times negative 1/6 will be minus 2. Actually, we've got to use that 12 again. I don't want to cross it out because we got to multiply the 12 times 1/6. Okay. So that worked out really nicely. So this will be negative 12x minus 2 equals 7. Add the 2 to both sides. Negative 12x is 9. Divide on both sides by negative 12. Looks like x is going to be negative 3/4. If you're partial to decimals, that'll be negative 0.75. Let's see here. So take this and we'll plug it in for the x over here. Negative 4/3 times negative 3/4 minus 1/6 will be y. So this makes a positive 1. Minus 1/6 is y. So y is 5/6. And there we go. X is negative 3/4. Y is positive 5/6. Okay? And again, that's why this problem doesn't really lend itself to graphing, is because it's hard to see, exactly what the value of x is if you're just looking at one of those little grids. Okay? All right. Now, what if we wanted to do this the other way? So we'll say 4x plus 12y equals 7. Negative 8x minus 1 equals 6y. Is that how that started out? Yeah. Okay, so if we want to do this by adding the equations together, I've got to put this 1 on the other side and move this 6y to be over here. So now, we've still got that first equation, but now we've got negative 8x minus 6y equal to 1. Okay, so now we've got a choice. We can multiply the bottom by 2 to cancel out the y's, or we can multiply the top by 2 to cancel out the x's. Doesn't matter. I'm going to multiply the top by 2 and then work to cancel out the x's. So that'll make this positive 8x plus 24y equals 14. These cancel. This makes, what is this, 18y? Yeah, equals 15. Divide on both sides by 18. And y is, if we reduce that fraction, 5/6. plug it back in somewhere, and you'll get x equals -3/4. Okay? So this problem is a little bit trickier than some of those other ones that we had seen on the assignments, but you've got your choice of methods. Okay? So there's the substitution method, there's the adding the equations method. Like I said, the graphing method is kind of tricky, especially if your answers are not going to be whole numbers. Okay, well let's move on to problem 20. Okay, now we've got word problems. So, problem 20, all we want to do is translate this into an equation. I don't care what the answer to problem 20, what the value of x is. What is this number? That's not what I'm grading you on. What I'm grading you on is writing the equation. 5 times the sum of a number and 12 is the same as 4 subtracted from a number. And there we go. That's the end. We don't have to solve it. Okay? That's all I'm looking for. Alright, that subtracted from is very similar to less than. Okay? Let's see here. Problem 21. Grocer wants to make a 60-pound mixture of walnuts and Brazil nuts to sell for $5.99 a pound. So 60 pounds at $5.99 per pound. The walnuts sell for $3.99 per pound, and the Brazil nuts sell for $7.59 per pound. Okay? How many pounds of each should we put in the mixture? Well, let's see here. I don't know. It's kind of hard to say. It looks like we're going to need more Brazil nuts because I think this is more than the average of these prices, right? If you have equal amounts, if we had 30 pounds of each, then the price would be the average of these two prices. If it's less than the average, that means we have more walnuts. If it's more than the average, that means we have more Brazil nuts. Okay? All right. So remember how to set this up. You know, if we want to call these W and B, that's fine. We know that W plus B, or X plus Y, has to make 60, and so that B is going to be 60 minus W, or vice versa, whichever one you want to isolate. So now, this is saying that $3.99 times however many pounds of walnuts we have, plus $7.59 times how many pounds of Brazil nuts we have, should make 60 times $5.99. Okay? Now, we're going to replace this B with a 60 minus W so that we can solve the equation for W. So 60 minus W, and then over here we've got to do some multiplying. So, let's see what we get here. Oh, where did I put that calculator? First off, 60 times 599, 359.4. Okay, so 399W, 759 times 60, 455.4. Minus 759W. Okay, so subtract the 455.4. So that'll leave us 399W minus 759W. Over here, 359.4 minus 455.4, negative 96. Here, 399 minus 759, negative 3.6W is negative 96 divided by negative 3.6. W turns out to be 26.6 repeating, or 26 2/3 pounds. Okay? And so if we do 60 minus that, then our Brazil nuts will be 33 1/3 pounds. Okay? So that's the walnuts, that's the Brazil nuts, and there we go. All right, so that's problem 21. Problem 22 is filling a tank with 2 different hoses. So this tank is 1,900 gallons. Okay, and we're filling it with these 2 different spigots. Let's see here. One is 15 gallons per hour, and the other one is 55 gallons per hour. And we know that the 2 spigots run for a total of 60 hours. Okay, so if we call the number of hours for this one x, and the number of hours for that one y, we know x plus y has to be 60. Let's see here. I'll move the x to the other side. Y is 60 minus x. Okay, now it's 15 gallons per hour times x hours plus 55 gallons per hour times y hours should fill up that 1,900 gallon tank. And then we'll take this y equals 60 minus x and substitute it in for the y. And now we get to solve. So 15x plus, let's see, what is that going to be? 3,300? 3,300? I'll double check that. Okay. 55 times 60 is 3,300. Subtract the 3,300 to the other side. So that should be 1,400. Yeah, negative 1,400. And over here, 15 minus 55, that should be negative 40. And so then we'll just divide on both sides by negative 40. X equals 35 hours. So 35 hours on the 15-gallon spigot, and then the other one will be 25 hours, 60 minus 35, on the 55-gallon spigot. And there we go. Okay, that's it for the word problems. Now we get into the last couple assignments that we've been talking about over the past week or two. Rules of exponents and working with polynomials. All right. Problem 23. And don't forget, you have the rules of exponents on the formula sheet. So please do make use of those. X squared y to the 4th, and then 2xy to the 3rd cubed. Okay. So, this one is just going to stay the way that it is for right now. This one has to get raised to the 3rd power, so it's 2 to the 3rd, x to the 3rd, y cubed to the 3rd will be y to the 9th power, because we multiply the 3 times the 3. Now, when you raise a power to a power, you multiply. But here, when we're doing x squared times x to the 3rd, we add those exponents and get x to the 5th. Negative 3 times 8, negative 24, x to the 5th, y to the 13th power. And there we go. All right, problem 24. negative 2b to the third c over bc to the fourth, and then that whole thing is supposed to get squared. So, let's see here. I'm going to simplify inside the parentheses first. This b will cancel out one of those b's and leave b squared. 3 minus 1 is 2. Same thing here. The c will cancel out one of these c's and leave us with c to the third power. 4 minus 1 is 3. Okay, so that means we've got negative 2b squared over c to the third power. This is going to get squared. So negative 2 squared, negative 2 times negative 2 is positive 4. b squared to the second, 2 times 2 is b to the fourth. And 3 times 2 is c to the sixth. Can't simplify it anymore. There we go. All right. What's next here? Okay. Problem 25. We're going to do, let's see here, 3x minus 2 times x plus 4. So, we want to distribute the 3x here and here, 3x squared plus 12x, and then distribute the negative 2 there as well, negative 2x minus 8. And then the last step, combine your like terms. So, 3x squared positive 10x minus 8, and there we go. Problem 26 is similar, except it's a little bit longer. It's one of those ones where you've got a binomial times a trinomial. So, x plus 3 times x squared minus 2x plus 9. So, first I'll distribute the x 3 different places. So, x to the third minus 2x squared plus 9x. And then distribute the 3. So, plus 3x squared minus 6x plus 27. Okay. X to the third, positive 1x squared, positive 3x, and positive 27, and there we go. All right, last problem here, problem 27. So, important difference between 25 and 26 versus problem 27. Notice this is multiplication. This is multiplication. I'm going to write down problem 27. It's not multiplication, so don't get confused by that. Negative 4x to the third, 2x squared minus 5x minus 7. Subtraction, 4x to the third minus 3x squared minus 5x plus 8. Okay? Notice, there's a sign in between the parentheses, and that indicates that we are not going to distribute. We're not doing multiplication here. Well, I mean, I am going to distribute this minus sign. Okay, that's important. But don't try to distribute all of these things. Okay? So this just stays the same. And then we'll get minus 4x cubed, positive 3x squared, positive 5x, and minus 8. Because this is going to change all the signs inside that parentheses. Okay, so now our like terms, negative 8x to the third. The x squareds are both positive 2 and positive 3, so positive 5x squared. Minus 5x and positive 5x, those cancel each other out and make 0. Negative 8 and negative 7 make negative 15, and there we go. Okay. So, that's it for the sample final. Like I said, your final will be very, very similar. It'll have the same number of questions, the same types of questions, but different questions. As always with these, if you have any questions about this, please let me know.